Welcome students to our second video lecture on numerical summaries. In this one, we're going to be discussing measures of dispersion. You might know this more as measures of spread. So if you've ever heard the term standard deviation or range of data, then that is the topic that we're going to discuss today. So let's move forward. Again, these look a lot scarier than they need to be. These formulas have a reason behind them, which I will explain. But at the end of the day, Microsoft Excel has some really fantastic formulas that make this process so much simpler than it ever used to be. So let's get started. We're going to discuss each of these one at a time, but this is a great summary screen for you to know all the different measures of spread or dispersion. So the first one is very straightforward and simple. In fact, we've actually used this kind of idea with class width, where we take the largest value and the smallest value and we subtract them. And that tells us how far apart they are. The fancy term we use for that value is range. So the first data set I put on a number line. So there are number lines that I'm using throughout this example because spread means that it's across a wide range of values. And in order to be able to visualize that, using a number line really helps. So on top of the number line, the numbers that are in white are the data points. So there are 6 data points on the top, and there are 5 data points on the bottom. So on the top, the biggest data value is 26, and the smallest one is 1. Even though there are 2 of them, it's still the smallest value. So that difference gives us 25. So 25 is the range for the top data set. And for the bottom, you've probably already guessed it, it will be 5, since 11 minus 6 gives you 5. Moving into the next measure of spread is the population standard deviation. Well, as you can see, this formula looks a lot scarier than the one that we dealt with just moments ago. So let's break it down piece by piece. Again, I'm going to walk you through how to do it by hand, but never require you to do it by hand. So please keep that in mind. So let's look at parts of the formula up top. So we've seen this symbol before in our last video. That symbol is called mu, and it is a Greek letter that represents the population mean. Okay, remember populations have parameters. Parameters are Greek letters. So therefore, that value is the population mean, which simply stands for the measure of center for the population. And we've already done this calculation before. We add up all the values and we divide by the number of values. So since there are 6 data points, we're going to divide by 6. And all of those data values we add up, we get 60. So the population mean is 10. So what we're going to do is we're going to substitute that value into the formula. So now we have 10 up there, since we know what the mean is. So now the next step is to figure out the spread, right? We're trying to figure out how far apart the data is from each other. And now that we have a measure of center, why don't we just find out how far apart each of the data points are from that measure of center? So for instance, we're looking at data point 1. How far away is data point 1? Well, we could just look at the span there. So it's going to be a -9 because it's to the left of 10. So that becomes important in a moment. We want to know which side of the mean is it. And as you can see, the value 1 is to the left of the mean, so it's less. So we're going to use negative values to represent to the left. So that gives us 2 -9s because there were 2 1s. Let's figure out what the next spread is. Let's go from 10 to 3. That gives us a -7 because it would be 7 to the left of 10. We're going to record that value. Let us do the value of 11. Now 11 is to the right of 10, so we're expecting a positive value of 1. Now, how far away is 18 from 10? That would be 8 away. again to the right, so it'll be a positive value. We're going to record that. And last, but certainly not least, because it's a very big number, is the value 26. So 26 minus 10 says that these two are 16 apart. So we'll record that value. So now that we have all the data points and the distance they are from the mean, let's just add them up, right? Because that should give us a spread. The problem is the mean is designed to make sure that the values to the left are just as far away from it as the values to the right. So we perfectly have 0. This did not tell us anything about how spread out the data is. So what do we do to correct that? Well, how do you add negative numbers and positive numbers without getting 0? Well, you have to change something. So what we do in the formula is we square everything. So I brought it to this screen so you could see that. So we had -9, -9, -7, 1, 8, and 16 were all of the distances left or right. If we square all of those distances, we get positive values. And that's fantastic because now when we add those, it'll tell us how far spread out everything is. Now, if you know a little bit about math, you might know about this thing called absolute value, which would also give us only positive values, but that's a lot harder to undo afterwards. So we square it because in the end, we can take the square root and get back to the same unit of measure. It's also quicker to do computationally than the absolute value. And it's what statisticians have used for a while. So with all of that said, that whole entire numerator in that fraction up there, that long thing that shows all of the different data values minus the mean, all squared, all added up, ends up just being the sum of this last column in the table. And that gives us a grand total of 532, which we plop back into the formula on top, as you can see over here. And we divide by 6 because there were 6 data points. And now using Excel, you can type that in. In Excel, it would be equal SQRT, which stands for square root. So that will be also explained more in the workbook. But with all of that said, the population standard deviation for this data set is 9.4. And that is a lot of work to get one value. It'll be much easier to tell Excel to go to standard deviation using the equal stdev.s. And that will allow us to just calculate the standard deviation without all of this. You do need to be aware of whether it's the population or a sample though, because those two formulas in Excel are different. I'm going to show you that right now. If we're talking about a sample, we have this n-1 because we are guessing and we lose a little bit of surety. So we're going to divide by a smaller number. So let's walk through this. So we have the mean for the sample, just like we had for the population. We're going to calculate that the way that we know how to calculate the mean, which is a great review again. You add up all the data values, divide by the number of data values, and you get your sample mean, which is 9. So we're going to take that value and we're going to substitute it back in. We're going to subtract either side and find out how far apart the data values are from the mean. We're going to square them so we don't end up with 0. And then we're going to take that total for that column, substitute it into the formula. And now there's a 5 minus 1 because we lost a degree of freedom. We're going to discuss degrees of freedom in a lot more detail. But basically, because we used a sample to estimate the mean, we lose our surety of the result. So that n-1 compensates for the fact that we estimated for the parameter already. So we're actually using a sample to determine the sample. So that's why it's 5 minus 1. So it'll be 14 divided by 4. And then we'll take the square root again. And that gives us 1.9 for this data set. Okay, you knew it was coming. Of course, we also had the situation where we had to deal with table data. And that was a really complicated situation when we went to figure out what the sample mean was for a table of values, especially when we didn't have the data values themselves, but instead an interval. So just as a recap, that interval, we take the midpoint. So in the first row, you see 200 minus 300. The midpoint is 250. That will be our data value that we use to multiply by 897 of them to get the total amount for that data value. And we do that for every single data value in the data set, using the frequencies as a multiplier to get how much each of those is worth, and summing that entire column to help us get the sample mean by then dividing by the total number of data points, which is also the total frequency. Hopefully you took your time in the last video, but this is just a recap of that same problem. Now we need to use this answer, which was 528.2. I used 530 for simplicity of calculations, but when the computer does it for you, you don't have to worry about that. It can handle complex calculations. So what we're going to do now is we're going to play the same game. We're going to take the data value, subtract the sample mean. So we have the first row, we have 250 as our midpoint. That's our data value. We're going to subtract 530. That's going to give us negative 280. We're going to square it. And then we're going to multiply it by the frequency because that's how many of those data values are there. Remember the one that we had two ones and ended up with two negative nines. This is the same situation, only there's a lot more of them. Instead of 2, there are 897 of this data value. So we're going to multiply, and then we're going to add all of that up to get the numerator, substitute that in. We're going to divide by the frequency minus 1 because we did do an estimate. It won't really matter as much here because the value is so huge already. But it's important to do the correct computation for a sample versus a population. And we'll get the value of about 107 for this data set. Now there's a lot more variation here than in the previous data sets. The values are also much larger. So it can sort of be expected. Now we're going to play that matching histograms game again. And this is the last part of this video. So using everything you know about measures of center and standard deviation, can you match the graphs? I encourage you to pause this video right here, right now, before continuing on. And once you've tried to figure out which graphs go with which labels, you can unpause the video. Okay, so using what we know about measures of center and looking at these graph labels, let's see if we can figure out what might go where. So it looks like the mean and median match for all of these graph labels, which means they should look relatively symmetric. They might be a little off, but not too bad. So that doesn't help us much at all. So let's look at the 53, 53, and the standard deviation of 1.8. Now, that means that there's not going to be a lot of standard deviation. It's going to be really tight around the value because it's so small of a standard deviation. So if we look, which of these seems to be the tightest pushed together? Now, perhaps you said B. As you can see, in the horizontal axis, the values don't have as much of a spread as in the other graphs. Also, the mean and median look to be about 53. Now, the next one's a little bit easier because the value is so high for the mean and median. So really, there's not too many possibilities here for where that middle might be. Have you guessed it yet? Yes, it's D. And you can see that because 62 looks like there's a peak there, but there's some lower values that are pulling on it. So I would imagine that the mean and median will be a little left to that big high frequency past 62 that pulls it over a little. Okay, we have two more. Now the last two clearly are A and C. So which one looks like it has a much greater spread? So as you can see, C has a much larger spread. So that'll probably be graph label 4. So it'll be 3, then 4. I hope you had fun with this game and this video, and now understand a lot more about spread. The Excel workbook will make your life so much easier, so I really hope you engage with that workbook in its entirety and really learn how to use Excel to make your life a lot simpler when it comes to calculating these numerical summaries. I'll see you in the next video.